So we're talking about the idea of special triangles, which is when two triangles have two angles that are exactly the same. And then we talked about the scale factor k, which is how you can get side lengths from one triangle onto another. Let's see this one. Again, the concept is very straightforward. I think there's nothing tricky about this. So there's a tree. So let's say this line is a tree, and then there's Nora, who's over here. She is 172 centimeters tall, and her shadow is 3.2 meters long. Okay, so is the shadow going to be in this direction, or is it going to be in this direction? Or can it be in both?
It could be both.
It could be both. But if we look at it this way, let's say this is her shadow, and then the tree is gonna cast a shadow by itself. If we say the sun is this way, right, you'll see that this problem may not be doable because actually maybe it still will be. Because both of them have right angles, and I guess this angle could be the same, but we don't know for sure. So this could work, but I think going it this way would make more sense. So this is her shadow, right? And this
Mhm.
entire thing, this entire thing will be the shadow of the tree. Then you connect them like this. And here we know for a fact that two of the angles are the same because they both share 90 degrees, and this angle down here. I think this approach would be a little bit better. Let's check it both ways because I think it's kind of interesting. Let's see if we get the same answers. So we're saying the sun is this way here. And then on this one, the sun is over here. All right, so what else do we know? Her shadow is 3.2. So from here to here is 3.2. On that other diagram, it'll be this one would be 3.2 up until here. At the same time, the shadow of the tree is 27 meters long. So this entire thing would be 27. So this entire thing would be 27. Now the question is, how tall is the tree? So we're looking for this side length. All right, so what's our approach here?
You find the scale factor by doing 27 over 3.2.
Right, so the answer here for the height of the tree will be the scale factor times 172, right?
Mm-hmm.
That'll be the whatever that is. What about on the other one? What about on this side?
You would do the same.
Yeah, you would do the same if we're assuming that this angle is the same, right?
Mm-hmm.
And that's the issue, I think, with this approach, because is that the same angle? Yeah, that's the issue with this, but the answer is gonna be exactly the same. I'm trying to see how we can show that this angle is the same as this angle. I guess if you draw a vertical line here, then we know these two vertical lines are parallel, right?
Mm-hmm.
You can only say that that angle is the same if these two lines are parallel. So I guess if you should do it this way, but the answer is going to be exactly the same. Nothing really changes. 3.2 times 172 and whatever that is on a calculator, and you're done. Cool. So just something to know here is that the answer for the height of the tree is going to be in centimeters because 27 is in meters The other shadow is also in meters, but her height is in centimeters. So when you do this calculation, the meters are going to cancel out. And the final answer for the height of the tree will be in centimeters. How many centimeters in a meter? It's 100, right? So 100 centimeters makes 1 meter. And 1,000 meters make 1 kilometer. There's one more. How many millimeters in a centimeter? Maybe this will help. If I can find it right here. So you see this is 1 centimeter from here to here.
Mm-hmm.
How many millimeters do we have is the question. There's 10, right? If you I know it's hard to see, but if you have a ruler, in the middle you have the 0.5, there's 10. So there's 10 millimeters in 1 centimeter. So these are some real life conversions factors that you can use. For time, it's easier, right? For time, it's like 60, 60, 60. Time is fine. But this one is like 10, 100, and 1,000. Oh, we don't care about pounds or whatnot. I mean, we do, but it's not really used that much. Pounds and miles and whatnot. It's not, it's more of an American thing. Let's look at this one. A right angled triangle has side lengths 6, 8, and 10. So 6 and 8, you can put them anywhere, but 10 must be here. 10 cannot be the other two side lengths because it's the hypotenuse. The longest side always must be the hypotenuse. And it says the longest side of a larger similar triangle measures 15. And now the question is, find the perimeter and area of the larger triangle. All right, what's our approach for this one? It's the same idea as any similar triangle question. Basically, you're just going to find the scale factor. What is it here?
1.5.
Yeah, 1.5. So this will be 6 times 1.5. It'll be 9. This will be 8 times 1.5, which is a 12. It's asking you for the perimeter. Just add 3 sides up. So that's 9 plus 15 plus 12. 24 plus 12 is 36 centimeters. And for the area, it's just going to be 9 times 12 over 2, which is 54 centimeters squared. Cool.
Mm-hmm.
Here's how you can find the area using a different approach for the larger triangle. Briefly talked about this yesterday. The area of the small triangle times k squared, you need to square that k, will be the area of the bigger triangle. So here the area of the small triangle is 6 times 8 over 2. K is 1.5. You need to square this. So what is this? 24 times 2.25. So that'll be 48 plus 6, which is also 54. So that's how you can find the bigger area if you know the area of the smaller triangle. Again, pretty simple concept. Just keep this in mind. Side lengths, you just multiply by k to get the bigger side length. But for area, you want to multiply it by k squared. And the harder questions are always going to be the ones where they don't give you a diagram because you may have to make some assumptions. So here, there's a flagpole. He placed a mirror on the ground 5 meters from the base. Again, this can be in either direction. So the mirror is right here, and this distance is 5 meters. and then she steps back until she could see the top of the flagpole reflected in the mirror. So from here, she's stepping back. She's somewhere here. We don't know the distance, but we do know that her eyes is 1.5 meters off the ground, and she's looking at this mirror. When she looks at this mirror, she's seeing the top of the flag on the same mirror like this. What's the last piece of the puzzle? It says it's 1.25 meters from the mirror when she was. So this right here is 1.25. And the question is, how big or how tall is the flag? All right, so what's our approach here? And so first up, they're both right angle triangles, right? Because we're drawing it straight down, they're both vertical. Second thing is we need one more to say they're similar triangles. We need to show that they share two angles. The only other angle they could possibly share is this. Now, are these two angles equal to each other? They're not opposite angles, right? If it was like this, then yeah, it'd be for sure. But are these two equal? So this kind of comes from a little bit of physics. The answer to that is yes. So that's a hideous looking eye, but the point is this. When you look at something, okay, let's say there's an object here, you draw a vertical line, and then there's a mirror, in fact, here. So this light ray that's going this way is going to be reflected off of that mirror into this direction. This is called the incident ray. This is called the reflected ray. And the idea is that the angle of incidence, this is called theta I, is the angle of incidence. It's always going to be equals to theta R, which is the angle of reflection. Okay? So what that means is in this context, this angle up here, right? This angle up here is equals to this angle down there, which means this angle and this angle also must be exactly the same. So yes, these two triangles are similar. From here, it's super simple. Find the K value, which is going to be 5 over 1.25. That's a 4. So therefore, the height of the pole is going to be just 1.5 times the scale factor. It's 6 meters. And you are done. Is this easy? Let's see this last question. He's designing a flag for his hockey team. The flag will be triangular with sides. Ever seen any flag that's triangular?
Yes.
There's only one, right? In terms of countries, like country flags. Which country is it? Every other flag is like either a rectangle, some of them are squares. But if you look into it, there's only one country
Is
that has.
it Nepal?
It is, yeah, that's the only country. In fact, they have two triangles on their flags. It's pretty unique. There's a video somewhere out there, or there's a set of, let me actually show you. This is kind of like has to do with maths. So those triangles, you can draw them, but the rules for drawing those is super convoluted. All right, here you go. We're not gonna do this. This could be like a project for you later, but for anyone who's interested. So there's an actual guideline on how to draw the flag. It's part of their constitution. And this is all triangles. So let me click these. So you see, you start with something like this, right?
Mm-hmm.
Let's just go through this. How many pictures are there? So step one, you're gonna draw this line. It has to be perfectly horizontal. The scale, I guess, depends. It'll fix itself. The scale will fix itself. And then you have to draw another line that's like 1/3 of the original line. And then you just follow this. And then there's some circles that come into play, and there's a lot of geometry that comes into play to draw this flag. It's actually pretty impressive when you think about it. And then eventually you'll get like this diagram and then you color it in. But you can see those shapes in there, right? We have a circle, we have a semicircle, we have a bunch of triangles, we have a bunch of rectangles. Yeah, it's pretty interesting. But anyways, going back to this question. So I'm assuming this is a right angle triangle. Actually, we don't know if this is a right angle triangle, so I'm not gonna put the 90 degrees there. All right, so that's the smaller triangle. Let's look at the bigger triangle. Here's where you have to be careful. We know the hypotenuse of this is 30. It has to be the biggest side, or actually it doesn't really matter, but the biggest side over here was here. Let me redraw these triangles because it doesn't say anything about it being a right angle triangle. So let me draw it like maybe like this. Right, there we go. You see how the biggest side of this triangle is on the right side?
Mm-hmm.
Same thing should be over here. Now the question is down here, is this 20 or 30? Oh, sorry, 20 or 25?
25.
So if you look at it here, these two,
It's 20.
it's 20, right? The smallest has to be the smallest here, and a 25 will have to be here. Now the scale factor is 25, right? This over this.
Mm-hmm.
Now has he drawn it correctly? So if I multiply this by 25, I need to get this. If I multiply this by 25, I need to get this. So let's see if that's the case. 1.2 times 25, that's 30. 0.8 times 25 is also 20. So the k values for all three sides are the same. Therefore, these two triangles are similar, and he's done it right. So here, part of a road rises 8 meters. So there's a road, maybe it's going uphill or something like this. This is your road, and it rises 8 meters. So let's say there's some angle here. Which side of this triangle is 8? Opposite, hypotenuse, or the adjacent? So which is the rise in this triangle? Is it the hypotenuse or the opposite?
The opposite.
So this is gonna be 8. Run is gonna be down here, right?
Mm-hmm.
So what is the question actually asking? What's the rise over run of 50 meters if the slope remains constant? So what's the slope right now? So the slope rise over run, right? Slope is rise over run. It is just 8 over 120, which is what? 4 over 60, 2 over 30, 1 over 15 is your slope. Not exactly sure what the second question's asking, but I think it's asking us this. Rise over a run. So there's another triangle here. But instead of the run being 120, the run is now 50. This is also a right angle triangle. These lines are going to be parallel. So that means this angle and that angle down there are going to be exactly the same. So if this is the case, what's our scale factor right now? We're looking at two similar triangles.
It's 120 over 50.
Yeah, it's 120 over 50. 2.4, I think. So our scale factor is 2.4. So we know the run is 50. How do we find the rise here? Using the scale factor. You're gonna do 8 times 2.4 or 8 divided by 2.4?
Divided.
Yeah, it needs to be smaller. You can also think of it that way. It can't be bigger than the bigger triangle, side length of the bigger triangle. So 8 divided by 2.4 is, well, it's 10 over 3. So what's the slope of the smaller triangle? What over what?
10 over 3 over 50.
10 divided by 3 over 50. Does the 50 go to level 2 or level 1?
Level 1.
Okay, let's see it. So we're doing 10 over 3, right? Divided by 50. You can put this in a bracket, but you don't have to. We're gonna do this first before we divide by 50. So it's 10 over 3 divided by 50. You'll see that when you convert this into 8 times, the 50 is gonna go in the denominator. So it goes to level 2. So here we go. The slope is exactly the same. And 1 over 15 before for the bigger triangle and 1 over 15 now for the smaller triangle. Part B says, why are the slopes the same? And it has to do with this angle right here. If this angle basically represents a ratio. If the angles are the same, that means the ratio is also the same. I can draw an infinitely many triangles here. All of these angles are going to be the same, and the slope of all of those triangles are also going to be the same because the angle is the same. Angle is the slope. What's the ratio of the slope? This is going to be unchanged as long as you have similar triangles, which all of these are. This thing is talking about the angle of elevation. Remember, angle of elevation and depression is always with the horizontal. So this is a horizontal line. This is the angle of elevation. And this is the angle of depression. It's always with the horizontal line. It's not with the vertical line. Like, let's say there's a plane here. Whatever. There's a plane up there. It's looking down at a city or something, right? Down here.
Mm-hmm.
This is the horizontal line. This is the vertical line. The angle of depression is this. It's always with the horizontal line. It's not this. This is not the angle of depression or elevation. It's always from the horizontal line. So in this case, let's say we have a ground somewhere here. There's two ramps. One of them is 3 meters long and one of them is 4 meters long. So let's say this is 3 meters, this is 4 meters. The question is, which ramp creates a greater angle of elevation with the ground? So the ground is here, right? Right here.
Mm-hmm.
So these are your triangles. What do you think? For which one would the theta be larger? I'll give you a hint. In fact, like if it was a meter, it'll probably be something like this. If it was 0.5 meter, it'll probably be something like this. If it was 10 meters, then you have a lot of leeway, right? Um, so how does this impact the angle? Does a bigger ramp mean a higher angle or a lower angle? I think that's the
Lower.
question. Yeah. So the longer the ramp is, the lower the angle of elevation will be, right? All right, let's move away from that. And most of the stuff we've done, it's honestly not that bad. Sine, cosine, yada yada. Let's just do a couple of them. So this one says determine the length of x and then state the primary ratios for theta. They are both right angle triangles, so you can use SOH CAH TOA only if they're right angle triangles. So for A, how do we go about finding the x? Well, for the first one, you can just use Pythagoras, right? That's it for the first one to find x, because you already know two of the sides. It's just going to be 64 plus, like that. Is that 17? 225? Square root of that, yeah, that is 17. So x is 17. Easy as that. And it says state the primary trig ratios. You want to use SOH CAH TOA. So it says state all three. So for A, sine theta, again, you have to look at it from the perspective of where the angle is. Is 15 the opposite or is it the adjacent relative to theta?
The opposite.
So it'll be 15 over the hypotenuse, like that. Cosine will be 8 over 17, the adjacent over the hypotenuse. And finally, tan is going to be opposite over the adjacent, so 15 over the 8. And that's it. You're done. Easy peasy. How would you find theta here? If the question asked you for A, find theta, what do we do? You will need to get rid of the sine. You can think of it as dividing both sides by sine, but that's not technically correct. So you need to get rid of the sine, right? What you do is you take the sine inverse on both sides. Sine inverse on both sides. What this essentially does is the inverse and the sine, they cancel each other out because they're inverse functions of one another. F of F inverse or F inverse of F is 1. They cancel each other out. And then the only thing you're left with is theta. So theta would be sine inverse of 15 divided by 17. That's how you can find that angle up there. It's not going to be a nice number, I don't think. Sine inverse of 15 divided by 17 is like 62 degrees. So that's how you can find theta, as long as you have a ratio. All right, for B, how do we find x? Again, it's a right angle triangle.
Pythagorean theorem.
Yeah, that's it. That's all you have to do. So here it's going to be plus or minus.
Minus.
Right, that's 169 minus 144. It's 25. Square root of 25 is a 5. So there you go. X is 5. From here, it's simple. Sine theta is 5 over 13. The opposite over the hypotenuse. Cosine would be what over what?
13 over 5. Or 13 over 12.
Good try, but think about which one's the adjacent and which one's the hypotenuse in this triangle. Is 13 the...
12 is the
Yeah,
adjacent.
so it should be 12 over 13. Hypotenuse is always going to be the largest number, so the bigger number needs to be in the denominator, and then finally tan theta is 5 over 13, and you're done. And if you want to find inverses, if you want to find the actual angle, since you have all three ratios, you can just do inverses, and all three of the numbers will be exactly the same. So you can do a sine inverse of 5 over 13. That angle is going to be exactly the same as cos inverse of 12 over 13. And both of these angles are also going to be exactly the same as tan inverse of 5 over 13, because it's the same angle that we're looking at. So any of the ratios can give you the angle. Sometimes you can only use one of the three. Here we could have used all, but sometimes you can only use one of the three. This one is slightly complicated. So let's say there is a triangle, right angle triangle. Beta is here, opposite, adjacent, and hypotenuse. In this triangle, what's sine theta equals to? In terms of OA and H.
Opposite over hypotenuse.
Right, so it's going to be O over H. Similarly, cosine theta is going to be A over H, right? If we need sine theta equals cos theta, that means opposite over hypotenuse must be equals to the adjacent over the hypotenuse, yeah?
Mm-hmm.
And notice they both have h's. If you multiply by h on both sides, the h's are gone. They cancel each other out. So you're left with O equals A. In other words, this side length is going to be the same as this side length. What kind of a triangle do we have now?
Isosceles.
Right. In an isosceles triangle, two angles are going to be the same, right? If two side lengths are the same, two angles down there are going to be exactly the same. So we know one angle is 90, and we know it's isosceles, so two other angles are going to be theta, so theta plus theta is 2 theta. And in a triangle, the angle always must add up to 180. So 2 theta is going to be 180 minus 90, which is 90. Theta is 45, and that's the answer. When this angle is 45, sine theta is going to be equals to cosine theta because the opposite and adjacent have the same side lengths. Does that make sense?
Mm-hmm.
Another more complicated way of showing this, because that question, the answer is limited to acute angles. So in that case, there's only one, which is 45. But if we think about it in this form, 1, 2, 3, 4, 90. 1, 2, 3, 4, 180. And then 1, 2, 3, 4, 270. 1, 2, 3. You can see where this is going. 360. So this is 45, this is 135, this is 225, and this is 315. The sine curve starts at the origin. Sine x starts here, and it goes up. You can think of this is where it's going to meet some critical points. Sine curve and cosine curve is going to come down because it starts at a maximum, but sine curve starts at the origin, and it's going to go up to 90, and then it's going to, because right now it's in its maximum value, it's going to come down to 180. Now we're in the middle. We need to go down to the minimum. It'll come to its minimum at 270, and then finally it's going to loop back to 0 at 360. This is sine of x. Cosine of x starts at over here, 0, 1. It starts at 1. It starts at its maximum value. Just like the sine, every 90 degrees, it's going to go up or down. We're already at a maximum, so it would not make any sense for us to go up from here. So we must come down. So it's going to look like this at 90. From here, do we go up or down?
Up.
So you need to follow the trend, right? It's always going to be this. From here, it's going to go down. So at 180, it's going to come down here. So now we're at the minimum, okay? It always works like this. It always goes from max to the middle, to the minimum, to the middle, to the max, and the cycle continues. To the middle, to the minimum, infinitely. So that's why we're already in the middle, right? We're coming from max. We need to go to the minimum. So from here, does it go up or down?
Up.
Up. So every 90 degrees, it's going to hit one of these critical points. So we're at 180. That means at 270, we're going to be down here. And then finally, at 360, we're going to go back to where it started at 0, 1. So that is the curve of cosine of x, right? Now let's see where they meet, because that's the question. The question was when is sine x equals cosine x or sine theta equals cosine x? One of the answers that we deduced from the triangle approach was this one. You see right here? It's where the curves intersect. So the first one is at 45. So that's what we had. Is there any other place where the curves intersect?
225.
Exactly. That would be the other answer. Okay. So this would be the reflex angle where they intersect. 45 is the acute. And that's another way to answer that question. But since we're looking at a triangle, there's no way we get a 225 because the three angles must add up to 180. So you're always going to see 45 as an answer for that question. But this approach also works. Explain why the value of tan theta increases as the measure of theta increases. Now, these are like good, like conceptual problems. So when theta is small, let's make it very small. This is a right angle triangle. So here maybe like theta is like 10 degrees or something. And then you can have something slightly larger, like let's say here it's like 45 degrees. And then you can have even larger. Let's say this is like 75 degrees, and this is the maximum that you can have. Let's say this is, again, it's not exact, but it's 89. Tan theta is opposite over adjacent, right? If you look at this one, which side is bigger? Is opposite bigger or is adjacent bigger?
Adjacent.
So when you go to do O over A for this one, this ratio is gonna be smaller than 1, right? You can just give you some numbers. Maybe O is 1, maybe A is 10. It's gonna be very small. It's gonna be way smaller than 1. Let me write it like this. Over here now, we have an isosceles triangle because we talked about this. 90 degree, if that's 45, up here must be 45. That means this side length and this side length are exactly the same. So if this is 5, this must be 5. So now what's the ratio of tan theta? It's going to be opposite over adjacent. It's going to be 5 over a 5, right? That's exactly 1. Yeah?
Mhm.
So when we increase the angle from 10 to 45, we see that the ratio goes from like 0.1 to 1. Let's go over here at 75. This is going to be much bigger than this. So let's say this is 9, this is 6. Tan theta will be 9 over 6. It's going to be 1.5. And then finally over here, maybe that's 20, and maybe this is 5. Tan theta is going to be 4. So the answer to this question is, when theta increases, does the rise increase or does the run increase?
The rise.
The rise increases, right? And the rise is the numerator. So as theta increases, the fractional component, the numerator of this fraction increases. So when the numerator increases, the denominator decreases. So as theta gets bigger and bigger, the ratio of tan gets bigger and bigger and bigger. Cool.
Mhm.
What's tan of 90? Let me see if I can go back to something that'll help us see what tan of 90 is. Let's go back here. Tan is sine divided by cosine. So tan of 90 will be sine of 90 divided by cosine of 90. Look at this diagram. What's the value of sine 90? It's the green curve. When x is 90, what's the y value? So we're looking at this point.
It's 1.
It's 1. What's cosine of 90?
0.
0. What's 1 over 0? Is 1 over 0 a 0?
No.
No, it's not. It's undefined. It doesn't exist. Okay? It's indeterminate. It's undefined. So that means in this right angle triangle, right? In this right angle triangle, theta can go up until like 89.99999. But this angle can never be 90. Okay? It's because if that angle is 90, we already have a 90 up here. This angle is going to be a 0. And you can't have a triangle with a 0-degree angle. If this was 0, if this angle was 0, then this line should be right on top of this line. Okay, just move it this way. then you would not have a triangle to begin with. So that's kind of what this means. The fact that tan 90 is 1 over 0 means in a right angle triangle, your theta can never be 90. If it is 90, then that triangle is undefined. There's a lot of bloat on this diagram, but the only thing that you need is what's h? This is given, this is given. Is this sine, cosine, or tan? You have to ask yourself, what is given, what are they looking for, and which ratio is going to work for that. Only one of the three is going to work for this.
Sine.
Yeah, it's sine. So sine of 35 is equals to the opposite divided by the hypotenuse. So h is going to be 18 times sine 35, and you're done. That's it. 2 steps. Whatever that is, if you plug it in, you get close to 10. Same idea here. Only one of them is going to work. Is this sine, cosine, or tan?
Cosine.
Cosine is right. Cosine 15 is going to be the adjacent divided by the hypotenuse. How do you solve for p here?
You multiply by p.
Good. You're going to multiply both sides by a p. So this p and this p is gone. And then you divide both sides by cosine 15, right? And yeah, you plug that in, whatever that is. It's 57. So this person's flying a kite. Let's say he's flying it this way. The kite is up here. And I can draw something like this. So that person was over here. He's flying a kite. His sister is standing directly below the kite, 8 meters away. So here's the sister. So in this triangle, which side length is 25 and which side length is 8?
The hypotenuse is 25.
Yeah, and down here is 8. And this would be the angle of elevation from Noah's perspective. It's always the angle up from the horizontal, or if it's a depression angle, it's going to be down from the horizontal. So is it sine, cosine, or tan?
Cosine.
So cosine theta is equals to the adjacent divided by hypotenuse. How do you solve this equation for theta?
You do cosine inverse.
Yeah, you do cosine inverse. So cosine inverse and cosine cancels out. Cosine inverse, this has to be in a bracket. It's not this. It's not cosine inverse of 8 divided by 25. That's going to give you an error because cosine inverse, what it gives you is it gives you the angle for the y value. And if you've ever seen a cosine curve, the y values can never be larger than 1 or smaller than -1. So cosine inverse of 8 means what's the x value and the y value is 8 for cosine x does not exist. You'll get an error. So that's why it's important to put a bracket here. So cosine inverse of 8 divided by 25, that is like 71 degrees. So that's the answer to this question as well. The angle of elevation of the string is 71. So this angle is 71. What if I asked you, from the perspective of the kite, what is the angle of depression to Noah? Remember, angle of elevation and depression is always from the horizontal. So if you're looking at the angle of depression from K, this is the angle that you're looking for. What would that be? Do we know, or do we need to do any calculations?
71.
It's 71 exactly, because these two lines are parallel, right?
Mm-hmm.
You can use the Z rule if two lines are parallel. This angle is this. You can also use the inverse Z rule. This angle is this. This angle will be equals to this angle, yeah?
Mm-hmm.
Because these lines are parallel. If it's a Z, then this corner will be equal to this. So the angle of depression here from K to NOAA is also 71. Here it says solve triangle ABC. And it says A is 90. So this must be 90. That's A. B somewhere here, C somewhere here. Small letter A is 7.8. So which side length of this triangle is 7.8?
Hypotenuse.
Yeah, it's the small a is always opposite to the larger a, so this is going to be 7.8 meters, and C must be this 5.2 meters. When it says solve a triangle, it's asking you to find all three side lengths and all three angles.
Mm-hmm.
How can we find this side length?
Pythagorean theorem.
Right, so it's going to be the square root of 7.8 squared minus 5.2 squared, which is 5.81. How can we find angle C?
You could do sine
Okay,
for any of them.
so sine C is equals to what?
5.2 over 5.81.
It's not 5.81 because sine is opposite over hypotenuse, so it'll be 5.2 over 7.8, right? From C,
Mm-hmm.
I mean, the hypotenuse doesn't change. It doesn't matter which angle you're looking from. The hypotenuse is always going to be opposite the right angle. So 7.8. Then you want to do sine inverse of 5.2 divided by 7.8, and that is 42 degrees. How can we find angle B?
You subtract from 180.
Right, so it's going to be 180 minus 42, which is 140, and then further 2, it's 138.
It's 48.
So you can look at it this way, right? Like, here's a quick tip for mental maths. This is the same thing as doing 180 minus 140 minus 2, right? Yeah, this is a
Mm-hmm.
40, and then 40 minus 2. What am I doing? This was supposed to be 42. So nothing changes though. So 42 is minus 40 minus 2, and 180 minus 40 is 140 minus 2. It's going to be 138. And that's it for that question. Pretty simple. Again, it's some things we've done before. Things get really difficult when, like, all of these things that we've done today, everything here is in 2 dimensions. The only time this is going to get super difficult is if you do it in 3 dimensions, which you may or may not see, honestly, at grade 10. Even then, it's manageable. If it's in 3D, we've done this some time ago. You want to find, like, an example would be something like this, let's say like there's a cliff or something. This is a three-dimensional diagram. It's not a very good diagram. Doesn't matter. You'll be given something like this, and you'll be like, hey, what's this side length? All you have to do is you have to attack the side that they both have in common. So this is the strategy for 3D. We'll see it some another time. All right, cool. Let's call it there for today.
Thank you.
See ya.